There's really only three records that mean anything to me. There is Mario Lemieux's unbreakable 5 goals in a game record. There is the lowest of the low Shakespeare My Butt record, which I bought in my early 20s. And then there's Java records. And I'll admit, if you're a Java developer, the first 2 records I mentioned there probably don't mean too much to you, but Java records should. When you use Java records, your code is less verbose. That means fewer bugs and it's easier to maintain. And also, the immutable nature of Java records means that Java records are faster and your applications will scale better. If you're not using Java records right now, it behooves you to start using them. And the thing is, they're not too hard to learn. If you just give me 5 minutes, maybe 10, I'll show you how to create records. I'll show you how to use records in your code. I'll show you some of the limitations of records. And finally, well, I'll make you an expert at using records so that everybody on your team, when they've got a question about records, they're gonna come to you. Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at TheServerSide.com, also the author of Hibernate Made Easy and a few Java certification books. And one of the things that really disappoints me is when I look at a code base where the developers are on Java 17 or newer and they're not using Java records because there are so many benefits associated with them. And that's kind of how I want to start off this tutorial, showing you the way we used to do things and showing you how much better it is when we use Java records. And that is exactly what we're going to do next. So to start off this Java records tutorial, we should probably talk about what a Java record is. Well, fundamentally, a Java record is a way to keep together logically related pieces of immutable data. And I guess we probably have to talk about what immutable data is. Well, immutable data is just data that doesn't change throughout the life of your application. And we deal with immutable data all the time in our code. For example, here I've got a stock chart of Tim Hortons from prior to them being bought out. And as this application runs, well, this program has had to go to a database, pull out all of the daily stock prices, present it on a screen, but none of that data that it is displaying here is going to change, right? The open and close price of Tim Hortons stock on October 22nd, 2014 isn't going to change. So that type of data that doesn't change throughout the life cycle of your application is a prime use case for Java records. And recognizing immutable data is a big deal because if you use a Java record and you recognize that certain data is immutable, your programs can run faster. You see, if Java knows that a piece of data is never going to change, it doesn't have to synchronize it. It doesn't have to protect it from threads that might want to update it. And if it doesn't have to do that, well, it can make your application run a whole heck of a lot faster. So you want to recognize immutable data in your programs. And when you recognize it, you want to create a Java class. Now, the way that we would previously deal with, a stock with a price range is we do something like this. You can see that I've got this class called price range, not a record, just a typical Java class. And this Java class has 3 properties, the high, the low, and the date for the given stock price. I'm not using the open and close date just to open and close price just to keep this simple, but you can see this class represents the daily price range for a stock. And this isn't unlike what we would commonly create in Java classes prior to records. Now, you notice that the fields there are all marked as final because, well, this is immutable data. It's data that doesn't change, and that's one way we can indicate that those fields, once initialized, won't change their values. Now, we then need a constructor, right? So we've got the price range constructor that takes those 3 variables, high, low, and date, and then assigns them to the properties of the class. Then we also need setters and getters. Now, if you've got immutable data, you don't have a setter. So we've only got getters here, but we've got get high. Well, that's going to get me demonetized, but get high, get low, get date, you get it, the getters. Now, with Java classes, if you create a Java class, you're supposed to implement a custom equals method, right? So that if somebody passes in an instance of the class, you can tell whether those instances share the same data or not. So I've got an equals method here, right? Check to see if the high of the current object equal to the high value of the one passed in. Do the same thing with low, do the same thing with the date. It's a lot of boilerplate code. And then we always need a hash code. And you should always have a toString method as well. So this is what a simple Java class would look like just to represent, I don't know, price range data that you might want to display on a chart in your application. And here you can see it being used, right? System.out.println, today.getLow, today.toString. We do create the class here. I'm using the var keyword instead of saying price range. But we do new price range, 1023, 9865. We use local date now to set it as the current date's range, I guess. And that's how we would typically manage immutable state in our applications, by creating a class like that. I'm going to save my code, run the application, and there you go. It prints out the low and it prints out the toString method as well. Now, that's a lot of code. That's verbose, and Java gets slagged a lot for being verbose. If you want to up your game, you use Java records. This is going to blow you away, and showing you how to reproduce this using a Java record, that's next. So I think we can all agree that the code on the left-hand side there is just a tad verbose, but watch this. I can replace all of that code, with maybe the exception of the import and package statements, with one line of code. I just declare a Java record. Watch this. Public record, price range, and then in round brackets, I write the components that I need. I need a double to represent the day's high, a double to represent the day's low, and then a local date, well, to represent the date of that particular stock trading event. I then put some squiggly brackets at the end there, click Control S to save my code, and boom, I am done. I now have a Java record, and behind the scenes, that Java record is going to automatically declare those three final variables for me. How? Why? Because that is in that method signature there of that record. It is going to create a constructor for me that takes those three values, the high, the low, and the date. It's actually called the canonical constructor. You don't actually get a default constructor when you use a record class. It's a big difference between a record and a regular Java class. So no zero argument constructor exists, just the actual constructor that takes all of the arguments, all of the components that you say is part of this price range object. Behind the scenes, it's actually going to create methods for me to allow me to access data inside that price range object. Now, you can see I've got the get high, get low, and get date method on the left-hand side. When you're working with a Java record, it's not a getter. So let me actually just declare this right here. So I've got var price range equals new price range, and new price range, and what is the price range? So 10, 12, local date dot now, just to put a date in there. That now creates the date. I have to do my import. That creates the price range object. And now I could just say system.out.println, and I could say price range dot, and you can see all the options, low, and that will print out the low for me. If I right click and say run as a Java application, you'll see that, well, that number 12 has been printed out. And of course, the first number is the high, the second number is the low. So maybe we have got some a validation that we should do inside of our constructors, but you know what? We can actually do that in the code, and we'll do that in just a minute. There we go. This should work better. The daily low is 10. I can even do the toString, right? So come over here and just print out the price range, which will trigger the toString method, run as a Java application, and boom, we get the price range printed out there as well. The high is 12, the low is 10, and the date is, well, the date is today. So we get all of the variables declared as final variables for us. We get that canonical constructor. We end up getting all of the getters. We don't get setters because it's immutable data. The data doesn't change. But we do get all of the getter methods, but they're not get high, get low. They're just dot low, dot high, dot date. We also get an equals method for us. It puts in a hash code method for us, and it even puts in a toString method for us. So all of that code on that left-hand side is replaced by this one line of code here, that Java record. And as I said, the Java record reduces verbosity in your code. That means that your code's going to have fewer bugs and your code is going to be easier to maintain. And since Java knows that all of the data in a record is immutable, it'll actually make your code more efficient, make it scale better as well. Now that's how you create a record, but there's some caveats about records, and there's some other interesting things that you can do with records as well, such as creating your own constructors or adding your own methods or even putting in static variables. And that is what we're going to do next. So I don't think I have to convince you about how cool Java records are, but when people are first introduced to Java records, they usually have a couple of questions. The first of which is usually about constructors, and namely, how can you customize this constructor that's automatically given to you? Just a moment ago, when I created a price range object, I transposed the high and the low value. And maybe inside your constructor, you want to do some validation, make sure that the high is actually higher than the low. And I don't know, maybe if it's not, we just set the high and the low equal to each other, something like that. Well, here's one of the coolest features about Java records. It's about how you can essentially override or customize the implementation of that canonical constructor that they give you, that constructor that takes all of the arguments that are listed in the Java record. All you have to do is type in the name of the record, and then a curly brace, and then you can actually put some logic inside of here. So I could say, hey, if the high is actually lower than the low, then I don't know, what do? We just set the high equal to the low or something like that. So at least the two numbers are now the same. And that's it. Now you notice I didn't have to initialize, this dot high equals high, this dot low equals low. Notice that in the signature of that constructor for the Java record, I don't actually have any arguments. I didn't actually have to put the argument list in. When was the last time you saw a Java constructor or a method where you didn't have to put the argument list in? But if you just leave it like that with a Java record, it just assumes that you're doing your own custom implementation here, and it'll initialize all of those values for you. So the constructor on the right-hand side there is still 100% valid. Now, some other cool things that you can do with Java records is you can put in static variables. So I could add a static variable here for the double called the biggest delta. Delta means change, right? The biggest daily change. So maybe as we're going through all of these records, we could check to see, if there is one price range that is bigger than, well, in this case, it'd be bigger than 0, but we'll keep a running tally. So I could do something like this. I could say, let me format this. If the high minus the low, so the difference, is greater than that biggest delta value, that static value, well, then the biggest delta becomes high minus low for this particular value. So now we've got static variables used inside of our application. We can actually put static methods in here if we want. I mean, I can even put public static void main in there. It's a common question. Can you put the main method in a Java record? There's nothing stopping you from doing that. So here you've seen me override that canonical constructor, but you can have your own constructors too. What if maybe if somebody just provides the high and the low values, we just assume that's for today, right? So if somebody doesn't provide the date, then that range is for today's date. We could implement that, public price range, and we could pass in a high and a low. And the only rule here is that you actually have to call the canonical constructor at some point in time. And there's a bunch of ways to do that, but one way to do it is with this keyword, right? High, low, and local date dot now. And now I've got a custom constructor that will work with this class. You can create your own custom constructor. You just have to make sure that at some point in that constructor, you're calling the actual constructor for the class, the canonical constructor. That's really the only rule. Do that in the first line of your code, and you are good. Now, what else can you do? Well, you can have static variables. You can have static methods. You can't declare instance variables. So I can't go double start price, right? Like if I try and put a new value into a record, it won't allow me to do it, right? It's got to be declared inside that declaration of the record itself. You certainly can't have a non-final property either, because these are supposed to be immutable. So can you see that red X there? So look at the red X. Can you see the red X? Okay, if you can see a red X, you need to get your eyes checked, because that's not a red X. That is a white X inside of a red circle. But besides the problems with your eyes, yeah, it says user declared non-static fields are not permitted in a record. So it would be fine if that was static. The problem with static variables, they stick to your clothes when you bring them out of the dryer. That's what I don't like about them. But you can't have instance level variables here. You can have static variables and static methods. And you can actually have instance level methods. So maybe, just maybe, I wanted to write some code that would, I don't know, get the average between the high and the low. So I could say public double get average and throw that in here. And what's the average? Return high plus low divided by 2. Isn't that the average between two numbers? I'll have to go look at my grade 13 calculus course, but I think that's right. And we could always go system.out.println price range dot get average. Okay, and now I can run this code, run as a Java application. What is the range? So it was, the low was 10, the high was 12, and there we go. The average is 11. So you can actually see all of that code is actually working right there. So there you go. I don't know, what are some of the other rules with records? One of the other rules with records is that you can't extend one of your own custom classes. So it's implicit that a record of yours actually extends the record class. So you can't go around extending your class. You can't go around extending other classes other than the record class. One of the other things too is these classes are final themselves. So you can't extend a record you created later on in your code. So kind of single inheritance here being enforced, the fact that records implicitly extend record, inherit from record, and these records are final. So there you go. That is everything that you need to know to start being productive right away with Java records. By the way, as I mentioned before, I am the editor-in-chief over at TheServerSide.com. If you're interested in Java, Jakarta EE, Spring Boot, software development in general, head over there. We've got lots of great tutorials. If you're interested in me, you can always find me on Twitter at CameronMCNZ. And if you enjoyed this tutorial, head over to Twitter, or X as the kids call it now, and send me a message and let me know that you saw this. As I mentioned, I am the author of Hibernate Made Easy, a few Java certification guides, also a very popular book called Pickering is Springfield, all about The Simpsons. So if you're interested, please check that up. And I think you can also see a book there by a young freelancer that we're working with over on the server side named Darcy DeClute, and she wrote the best-selling Scrum Master certification guide. So if you're interested in scoring highly on the Scrum Master exam, that's definitely a book that I would suggest you pick up. And there you go. I think that's about it. I guess the final thing what I would say is, if you're watching this on YouTube, why don't you subscribe on the YouTube?